So let's actually discuss a torque example and let's actually learn how to calculate torque, which is pretty simple. We already learned the formula in the previous video, which is that the turning effect or torque is equal to the product of force into the perpendicular distance of that force from the pivot position, right? So this is a pretty simple formula that you can use in order to calculate the torque. So let's actually calculate the torque for something. Let's say that there is a door like that, and you open that door. The door is here, the doorknob is here, and door opens up like this, and you applied some force on the door at this point, right, from the back, and the distance of that point from the pivot is, let's say let's say 0.8 meters, and the amount of force that you applied was, let's say, 4 newtons, right? So 4 newton force was applied at this point, and the distance of the pivot was of that force from was 0.8 meters, right? So it is pretty simple. You can just simply calculate the torque for, in this case, by taking the product of force into the distance. In this case, the force is 4 newtons and the distance is 0.8 newtons. So 4 times 0.8 is going to be 3.2, and the unit that you're going to use is Newton meters. We can simply see it from the formula. The unit for force is Newton and the distance is in meters, so Newton meters is going to be the unit. If the distance was provided in centimeters, then it would have been Newton centimeters, right? So 3.2 Newton meters is going to be the torque. Or in another case, you could be provided or you could be asked to calculate the the amount of force, for example. You could be actually you'd be asked to calculate the force, and the force is applied at this point. Let's say it is at the distance of 0.9 meters, and some force F newtons is applied, and the turning effect is provided. The turning effect is, let's say, 5, or let's say 4.5 Newton meters. You observed a turning effect of 4.5 Newton meters. So what is the amount of force that was applied in order to achieve that turning effect? Or let's say if the question goes like this, that the turning effect required to open the door is 4.5 Newton meters, and the force is now applied at a distance of 0.9 meters from the pivot. So calculate that force. So you once again simply need to use this formula, and this time since you're required to use the force, you can make the force subject, and it is going to be torque divided by the distance. The torque required is 4.5, so we're just going to write that here. The distance is 0.9 meters, so force is going to be 5 newtons. So 5 newton force is required in order to create a turning effect of 4.5 newton meters if applied at a distance of 0.9 meters from the pivot position. So it is simple mathematics. You need to, if you're given any two of the things, you can calculate the third thing easily, so you don't have to worry about anything. This is simple mathematics.